Okay, awesome. So it's about 3.
3x. Be sure to.
Okay.
Yeah, we need a pull out.
Oh, okay, backwards, right? First.
Yeah, so,
Okay. Or can't we, okay.
maybe I did.
Yeah. Why should go up and, yeah, wait.
A plus.
It's
A plus.
it's so, remember? Same signs and opposite signs.
Wait, same.
We're just, wait, I'll try it. I don't know. I remember so.
Wait, here's what I think it's the A plus B.
Okay, negative 20.
Oh, yeah. I'm not even right, okay, but I know it's like
Wait, do it.
it's like anytime you go so 9 and it's a 7, so 9 minus 7 is 2.
How did you get to
and
top of the
also,
bracket?
20, okay, wait,
You need to set
Okay,
the limitations because often.
I'm really. Okay, I did it. But direct line 7.
Yeah, go back.
Because I was,
As a stat, I mean, you have.
And then over,
X, my.
oh, yeah. Wait.
So it's only. So it's just like depending on whether or not those zeros were.
You do it once.
I don't think you need to do it. You don't? Because you just multiply it with 0, so.
But this would obviously do this.
Oh, I can't see it.
Direct line 7, it's just.
It's just 7 for 3.
Are you guys using P's and Q's down here?
He's in.
You want? Oh, you don't? I don't know. I want to see how you do it. How would you do it?
Wait, I'm not. I don't know. Okay, it's -2 and then. Remember you do all the factors. Okay, it's plus or minus 1, plus or minus 2 over 1. Because those are the factors of 2.
The bottom.
Oh, isn't it like?
You do plus or minus. Okay, so plus or minus 1.
Yeah.
And then plus or minus 1. Yeah, okay, it's plus or minus.
Well, no, because.
And then you just test. And then I'll okay, let's see if 2.
Oh my gosh.
Wait, I forgot. Okay, wait. 1, 0, negative, all negative 2.
That's like.
Yeah, I'll show you. 4,
Okay.
low. Oh, it works. Negative 4, 1, 2. Yes, it works. Okay. It works. The factor is 2. So it's, wait, but I forgot we used that.
One can overcome 3-1 deficit.
So I think it's negative.
I forgot we did.
That's motivation.
Okay, so we know 2 is the fact.
Why did you do this thing the first day?
Oh, because it's divided.
Like, I don't know if you can do this.
Oh,
The
because
bottom
the top.
No, we can't. It's divided.
Wait, but I.
We're gonna start going over this in about 10 seconds.
She was a factor. It's really weird. You go, you find, do you get this part?
Yeah, bottom.
Okay, and then you just test the numbers. You take the coefficient.
Okay.
Don't have to.
So finish up your sentence. Well, I'll give you some more time to do number 2, but I at least want to go over number 1. Did you all finish number 1? Okay. I need some help. We start with the parent function, I hope. With the parent function. Una, can you tell us what you did about the parent function here, please? So you said 1 over b comma -1, and then b1. Does this seem right?
Yeah.
So that's very general. So for this one, it's going to be specifically 1, 0, and then and 5, 1. So if you have these 3 points, then you have a great place to start. Thank you, Una. Could you all show me what that 2 is going to do to these 3 points? Show me what the 2 is going to do to the 3 points. Yeah, it goes vertical stretch with that x-axis in the middle. The 3 is going to show me what that's going to do. Move 3 to the right, and then the 1, of course, is going to move those points up. It doesn't matter which one we do first.
We need
Does not.
I'm down.
Yeah.
Just do the horizontal.
In general, multiplication division comes before addition and subtraction. So I just like the final points on the final 3 points on this graph. Una, do you want to tell us what the final 3 are, or should I? Okay. 4, 1, 8, 3. Now 16 may be on this graph. I wouldn't be surprised if it is, but that's not one of the 3 points I want.
Wait, no, 16/5.
Oh, 16/5, is that what you said?
Yeah.
Oh, okay. That makes much more sense to me. 16/5, otherwise known as 3 1/5. So 16/5, comma, -1. Do we agree? And of course, the feature I want to see, I'll show me the feature that I want to see. Yeah, I want to see that vertical asymptote at x equals 3, just to kind of reel it in. Okay. No, thank you. That's great. Any questions? Should we check to make sure that this is right? How could I check just to make sure I've moved? Yeah, let's plug in the point. How about 8 and see if a 3 comes out? Will that make sense? Just to make sure we did it correctly. Is that difficult to plug in an 8? No, log base 5 of 5 is 1, 2 plus 1 is 3. Things are looking really good. If it wouldn't have been 3, then we would have been in trouble. Okay. Number 2, what's a good strategy for this? What's a good strategy, like overall concept? Any?
I thought of it as a graph, so whenever the graph is greater than 0, or like meaning what's outside of like the graph's region, since it's an inequality.
Okay. Outside of the graph's region.
The graph
Ah.
would be outside instead of inside of like the parabola or the.
Oh, I see. I think you might be thinking of like y is greater than
Yeah.
the function, or x is, or yeah. This is greater than 0, so it's a little different. It's a little different. But yeah, so let's see some other ideas. L. Solve for the zeros, and why would that help?
I made or just to start.
Okay.
I made an equation and I solved for x.
Okay.
And then getting x equal to -3 and 7/3.
So you're focusing on the top because what happened with the bottom? Okay.
And then I separate your number line and I have the points -3 and 7. And then I plugged in each points in each of those 3 regions that separated to the negative region, the positive region, and the region in between.
Okay. So you didn't actually have to graph any. Okay.
And then from there, I got like the left side. So everything left to -3 is negative, or so smaller than. And then I got like positive. So then I could from there.
Okay. Mia, is that okay? So maybe I misunderstood what you're saying. Okay. So on the number line, Just trying to see where it's above or below. Does that sound like a little boundary algorithm? Okay, that makes sense. I'm sorry. Okay, I see. I thought you were talking about graphing above the, like shading above the graph.
It's x-axis.
Okay,
I mean, the graph definitely either touch or cross at -3 and 7 over 3 considered 0.
I see. I completely misunderstood. I'm sorry. Thank you. Yes, Simon, look, we got this whole row right now.
Just multiply the bottom and the other side.
That's a good question. Can we just multiply both sides by that denominator? Well, you could, and you get rid of it, but the question is it helpful? Maybe if we're just solving for the equation equal to 0. If we're trying to find out where it's equal to 0, I think that would help. But the question is definitely where is this greater than or equal to 0? So I think we have just a little piece of the puzzle. So we do have to consider the bottom here. We do have to, yeah, we have to do P's over Q's. So has anyone factored the denominator? Just one of you has factored the denominator. Please use P's and Q's. If your neighbor can't do it, maybe you could get some help from people in front of you, behind you. Factor everything. But the boundary algorithm, which you two are talking about, is exactly what we need to do, but we need some more boundaries.
So first, you take the last number, x cubed minus 3x minus 2, okay? You find the factors of 2 and the coefficient of this. So if you want to negative 2, yeah.
Okay, wait,
So the first coefficient. Yeah, and so you're gonna do plus or minus, the P is the one.
Wait, it could be negative one.
Plus or minus 1.
Plus or minus 1 and plus or minus 2.
Yes, yeah, no, it's so, yeah, so for the P's, P over Q, like division. So for the P's, it's plus or minus 1, plus minus 2. And the bottom, it's just plus or minus 1.
Okay.
And then P is a 1 on the right. You have to
P is one of them. Yes. And
You check?
Sorry?
Is that you check?
You tried.
Those-
Then what, yeah, what do you?
Okay, so then you have the 2 on the outside, right? You're gonna draw that. Okay.
Oh my
now
God.
you take Yeah, now you do the coefficient of, so what's the coefficient of x cubed? It's 1. And you don't have an x squared, so you assume it's 0. Okay.
Then we already negative stuff. We got 0, we got.
Well,
but now-
now we can try another number, or we can just do the quadratic one.
What do you do with 2?
Okay, so that's that.
Oh, so then what's?
Drop one.
Okay. Oh, yeah, I know.
It's for negative.
It's 2. Okay, so
Two.
try 2. You ready?
This one
1,
is
0,
underneath.
negative 3, and negative 2. Yeah. Okay, so we drop the 0. Now you, you add, okay? 1 plus 0 is what? 1. Multiply the 2 by 1, bring it up here. And then 0 plus 2.
Yeah, it's
Remainder you.
What do you do with the 2?
Yes, you mean? Okay.
Wait,
Yeah, I got the range here.
definitely got.
Yeah, okay, so now we rewrite it. 1x squared plus 2x plus 1. So we use this.
Right.
Does that make sense? Write down.
So you have.
Oh, because like it got rid of that skew.
We need 2.
No, you have to factor.
Now you just-
You factor
I
it.
understand. So
Wait, and this is just x plus 1 squared. So now, so the bottom's just x plus 1 squared.
Yeah, that's.
Yeah, and then we have to factor.
Alright, so
this.
that's
We can
x,
do the
that's x
quadratic
plus 1
one.
squared.
Oh, yes. Yes.
Alright, and then,
So x.
so now that we have that on the bottom, what does that do?
Now we have that, yeah. Remember, we know how to use that.
How do you get to copy?
That's me.
Yeah.
Okay, now we solved that. We got it. Okay.
You just need like,
Wait, we know the 0. X plus
So you
1.
get-
X plus 1. Is that like X plus 1?
Wait, is your try?
Oh, yeah, we also need X minus 2.
Yeah.
You were right, we need X minus 2.
oh yeah.
Yeah, yeah, all right.
I mean, sorry, 2.
So now there's a bunch of, so now it's x.
Now we have our cube.
Wait, but we know our x You know, negative one, like touches it and comes back, though, right?
Yeah, so now we remember how to do this from that.
Yeah.
Yeah. We are 0, are 7 over 3.
Yeah.
And negative 3. Wait, the at the bottom is another one.
Okay, that was.
The bottom.
Need a little bit more time?
Yeah, maybe it's 1 minute.
And then it's X plus 2 also.
Okay, so negative 1.
Oh, because I forgot.
Bottom vertical asymptote.
Okay, now we have to do those.
And then remember, this is a multiplicity of 2.
Yeah.
If the first.
It touches, so that means it's a boundary.
It touches and comes back.
It comes back.
It's a boundary.
It bounces, but we don't.
Then.
Wait, why do you have X minus 1?
That's a.
Isn't it just like- Sorry.
Okay, so I'm still getting the same thing.
Wait, I'm still, I'm sorry.
I'm between 2 and.
10 more seconds.
Then you have to like test all the regions.
Yeah, you plug in a number from each.
Oh, and then.
Okay, so ready or not? I just want to know how to factor the top. Nathan, can you tell us what you did for the top?
Yeah, okay, so for the top, I just used, I forget what the method's called, but.
What would you get?
Sorry?
What did you get in the end for the top?
Okay, I got 3x minus 7 and x plus 3.
Are we good with this, everybody? Did you use the diamond method or something like that?
No, I just used like when it's like, you draw like, okay, like 1 and 3 and like.
Oh,
and
you did
then 1, 2, 1
factors.
and 3 and 7.
Okay, so you found the factor pairs. That worked. Thank you. Yeah, I knew you'd be able to get that one for sure. It's a upper level kind of factoring, but eventually you can get it. I need some help with the bottom though. That one's pretty tricky. Yeah, Jonas?
If you do P over Q,
Mhm.
you can find that it's able to be symmetrically divided by 2.
It's what?
It's able to be symmetrically divided by 2.
Able to, okay. So specifically, what are how many P's and Q's over Q's are there? Are we good with that? Plus or minus 1, plus or minus 2. So there's 4 different ones. Okay, and did you find that one of these worked?
Yeah, I think I found it to work.
So 2. How do we check to see if 2 works?
Division, and if you get that was 0.
Okay, so synthetic division, we put the 2 right here, and then outside that box would be 1, 0, -3, and -2. Okay, so this works, you're saying? Oops, that's 1. Really? Oh, such happiness. Okay,
Yeah, x plus 1 squared.
okay, so with that 2, we now have a factor of x minus 2 on the bottom, right? And then with this, we get
No.
x plus 1 squared. This is x squared plus 2x plus 1. Does it bring back some good memories? I know.
Then you just make a number line.
Yeah, we make our number line. We do our boundary algorithm. We know that there are 4 numbers that when you plug them in, you get neither positive nor negative, right? So specifically, starting from the left, and Jonas, thank you, by the way. -3, then -1, and then is 2, and then 7/3. So how many regions are there? There's 4 regions.
1, 2, 3, 5.
There's looks like there's 5 regions because there's one over here, right? There's one here, right? Where's my eraser? Region 1, region 2, right, etc. And I know if I plug in that -3, I'm going to get a 0. So I'll put a closed circle there. And the same thing over here. I know if I plug in a -1, math will explode. So I'm not going to plug in -1. And if I plug in a 2, the same thing. I don't want any explosions. So those are open circles. And if we're doing a 2-dimensional graph, those, of course, result in vertical asymptotes. So vertical asymptotes. Okay. So there are 5 regions. Please check with your neighbor. How are you supposed to figure out if it's positive or negative? These regions.
So.
What would you consider the
Right, the same. Well,
Yeah.
They
They can't.
Well, I plugged in.
Don't want to. Not on your birthday.
Come back. Okay, ready?
Yeah.
Okay. What should we plug in?
I don't know.
You're plugging a little zero.
Yeah, zero.
Okay.
One of, oh, because I was one
Plug in zero.
Okay.
Okay. So
Yeah, we know.
Okay, you get -7 times 3. So that's a negative over a. Yeah. Negative over a negative. There's a positive.
So it's positive.
It's negative.
Oh, so plus. Just put pluses on top of it.
Okay, wait, ready? Wait, here. Okay, wait, no, isn't computed here, isn't zero, plugging zero to the negative? No, you're right.
Positive.
Positive.
Are we good?
This is over and then this.
Okay, should we plug in 5 different values? Is that how to proceed from here? Is there 5 different regions?
Yeah. Look at one, and then you should make one.
Because you.
Just one?
Oh.
Plug in a 0? Let's plug in a 0. The 0 is a nice one to plug in. Should I plug it into original or the factored form?
Doesn't matter. Original.
Doesn't matter.
No.
Probably the easiest one, don't you think? I think for 0, the original one's easier, isn't it?
Yeah, it's negative.
It's just negative over negative. We see. This is definitely a positive right here. And if I'm going to the right, in this little space between the 2 and the 7/3, I know it's going to be negative.
The multiple.
Yeah, multiplicity of 1, and then on the other side of that 7/3, it's going to be positive. Going the other direction between -3 and -1, it's positive because, yeah, multiplicity of 2. Could you show me how that results on the graph? What kind of feature are we looking at? Now we have a a vertical asymptote there, so it would look like this, right? It's going up on both sides. It doesn't actually touch that x-axis. And then, of course, after negative, from on the left of -3, it is it's just a multiplicity of 1, so it's negative there. You want to check by plugging in any numbers somewhere? If you are going to plug in some numbers, please make sure to plug them in now to the factored form. If you're going to plug in a -4, just plug it into factor and see if it's positive, negative, but it is a complete waste. Yeah, that's true. You could do that, but even it's a complete waste of time because we already know just based on the multiplicity. Yeah, Max.
Why is the -3 to -1 region positive?
Look at the square.
Because -1 has a multiplicity of 2, so it doesn't change on either side.
Oh, okay.
So we have that asymptote is same behavior.
If -3 had a multiplicity of 2, would that also be positive?
Yeah, it would also be positive. Yeah,
Okay.
but that would actually be a physical bounce because it touches it.
So if it was just x plus 1 by itself, and then x plus 3 was squared instead,
Mhm.
would the -3 to -1 area be negative, or would it be positive?
So you're saying if the multiplicity on the bottom was if these two were reversed, so if these
Yeah.
multiplicities were reversed from the -1 to -3, yeah, then it would alternate on either side of -1 and then stay the same on either side of negative.
Okay.
Yeah, good question. And if you're not sure, right? If you're not sure, just plug in -2. Let's plug it in at -2, make sure it's positive. If I'm plugging in -2 up here, I have a negative times a positive. And let me write this down. So x equals -2. We have negative times a positive over, again, I'm plugging -2, so that's negative. And then whatever I plug into this is going to be positive. So it doesn't really matter. So it's positive. It's just a little bit of waste of time because we know multiplicity. Or once you understand that idea, it should make life a little bit faster. Any questions? Oh, I did have a question, and we'll finish this up in just a minute. Instead of using synthetic division to check that two, did anyone check to see if that two is a zero a different way here? Because there's another way. Long division, or what's that? You get craft, man. That's a little too much.
With the Y intercept.
Oh, just plug it in, plug in a two. You see that? Yeah. 8 minus 6 minus 2, you get the zero. Like we're checking to see what's a zero. Same thing with -1. -1 works. So you don't have to use the synthetic substitution, but it's a tool. Yes.
The like x minus 2 and x plus 1 squared, we're considering them zeros in this instant, but not necessarily asymptotes.
There's zeros of the polynomial that's on the denominator here. Yeah,
Then we make them open circles, so we know they're technically asymptotes.
right.
Oh,
Yeah, so every number in here, in the rational function, it is a balance on whether it's positive or negative. So we had to balance everything. We couldn't just look at the top. So the final answer, I'm going to call on someone for the final answer in just 10 seconds. Make sure that you wrote it correctly. If we haven't answered the question yet. Let's solve for x. For what values of x is that function greater than or equal to 0?
Why not open it?
Oh.
Oh.
It's a negative speed.
Oh,
I see. Yeah, I guess me too.
wait, I got the answer.
Oh, not yet, not yet. Destiny has called someone. Are we ready? Max, what'd you get?
I wrote it in interval notation.
I like that.
Did close bracket -3, comma -1.
-3, comma -1.
I
Okay.
did like a bracket again.
Close or open? Okay.
Oh, wait, open, my bad.
You broke math almost on someone's birthday.
Yeah.
Okay.
And then, I did like the union, and I did -1 with the open bracket. Comma 2, close bracket. Oh, wait, no, open bracket. And then I did, union, close bracket 7/3, comma, infinity. And I did
You didn't close a bracket on infinity? You sure? Okay. Any questions? Do we really need this -1 stuff? Can we just go from -3 to 2? Would that be okay?
that would be so.
Maybe you write.
Ooh, silly. You're right.
-1, like for x doesn't equal -1 below 1.
Oh, so if you want to do something like -3 to 2, but then like x does not include -1, something like that. I see what you're saying. I would appreciate that. If you did it, I prefer this one because if it's interval notation, let's just keep it in interval notation instead of a mix between interval and algebraic. But it's mindful, so I like that. But as long as it's right, I'm quite happy with that. And yeah. Any questions? Is that a good warm-up or what? And that first one diving right into it? But fired up? Hey, too warm. Too warm. Okay. We have to do the actual packet. Just so you know, the homework tonight will be on Pearson. It's a Pearson assignment. And the packet is the lesson. So let's get this party started. Well, let's continue this party, I should say. With solving exponential and logarithmic equations. Welcome back. Welcome back. Okay, so we have this lovely fraction here. The question is asking solve for when it's equal to e to the 1/2. So, oh, this is page 5, is it? Is that right? Okay, so I'm just going to take this function. Instead of e to x to the 5th, how can I rewrite that top? Thank you. It's just multiplication there. Over e to the 1/4, and I'm setting that equal to e to the 1/2 is how we make that an algebraic equation. Next step. Oh, that's a good idea. We have the same base on top and bottom, so we could just make that e to the 5x minus 1/4 equals e to the 1/2. What do you think? Yes?
Yeah, and then you just get rid of the e.
Yeah, since they're both e to the whatever, we can make this 5x minus 1/4 equals 1/2. And from there, good luck. I'll give you just a minute. Okay, Judy, what'd you get? Three-fourths. What do you do to both sides here?
Divide by 5, so 3/10.
Right, you just divide by 5 or multiply both sides by 1/5, which might be just a little bit more elegant. We're solving this one, but you got it perfectly after a little, tiny little fumble. Are we good with that? X equals 3/20. Thank you, Judy. Nice done. Okay, let's try this next one. I hate over parenthesizing. Are those parentheses really necessary? I agree with you. So e to the 3x minus e, and we want to set that equal to 3e. How should I do this one? I could move the e. I'm not going to. Instead, I'm going to move that 3e so I could use. Yeah, why would I want that 0? Refactor it. What should I do now? How about we get rid of the 4? Let's divide by 4. That's not a bad idea. Simplify things at least. But now what? The whole point of setting equal to 0 is so we can use ZPP, which means next step would be to factor ZPP, zero product property. I'll factor out the E. Do you know how to factor out an E from there? Eventually, I think we'll have to use that one. Yeah, the factoring out an E. Is that what you mean by take out an E?
But how can you take out the exponent alone?
Right? Carefully.
Oh, wait, you could take out e to the 3x. Fine.
So 2 to the
Wait,
And then you can divide by 2 ln.
Wait, Hodge.
does that work?
You can see it.
Wait, how do you use?
Because this is e to the first, isn't it?
Yeah, it's just.
No, I get.
So now I have two equations, e equals 0 and 2e to the 3x minus 1 minus 1 equals 0. Yes,
How can e equals 0 if e is like a set?
it can't. It makes no sense. I had to just miss that. Thank you. Yeah, it's not a variable. Did you finish? Finished? The factoring?
Like, yeah, well, count right.
I'll talk about that in just a second. Sure. Yeah. So 3x minus to the third.
Oh, actually.
I'm not sure. Maybe.
Can also write equals divide by 2. So I don't understand.
Yeah, I know that's.
Okay, and then that's. If I press share.
Yeah, I think I got it. I got it.
Oh, times E. At the bottom. Add an E, and then it becomes ln.
Wait, hold on.
Minus 1
Hold on.
ln.
Shimon, I got ln 1/2 minus 1 over 3. Wait.
I got. I'm confused.
Wait, I got minus 1.
I think
Okay.
Wait, you just take ln.
To solve this one?
Yeah, no, I think you're right. Yeah.
Yes, Haley. Thank you. So, and then of course you divide by 2. Did we get here? And then what'd you do from that?
I did like natural log on both sides.
Why did you choose ln? Nice. ln on both sides. So you got
Natural log 1/2 plus 1.
Good work. That's good. Yeah, wasteful.
so natural log 1/2. So x equals,
Natural log 1 plus 1 over 3.
okay. Are we good with that? Nicely done. I do want to talk really quickly about this factoring because I know it's a little bit tricky about factoring. So if you could factor this, and this, I'll just put this on the side, and I think you could all do this pretty easily. If you factor this one, sometimes it helps to just go back to something that's a little bit more sane, don't you think? Like here I hope it's obvious we could factor out x squared. And when I do that, this becomes x to the, where did that 3 come from? 5 minus 2, right, is 3, and this of course is a 1. So I'm just doing the same thing here. When I factor out that e, it's a 1. So I had the e to the 3x. So when I factor out e to the 1, I just subtracted that 1 from there. And you can see that it's actually pretty clean when if I were to multiply that back out, that minus 1 and plus 1 would cancel one another out. But yeah, it's weird. Right, it's weird. And then to say E equals 0. Who would do that? Who would do that? Not us. That would be, yeah. Make some questionable decisions in life there. Okay, moving on. Oh, that was a good time. Okay, here's some general directions. So if your equation has just a single log or a single exponent, the first step is to isolate the exponential or log expression on one side of the equation. And then I wonder what goes in that blank. Convert the equation to alternate form. Thank you. I like it. And then solve for the variable if necessary. Simplify and or round answer as directed. Okay, so I'll give you a moment. B annoys me. What's the point of those parentheses? I don't know. I don't condone them. But I do condone you doing A, B, and C.
Once you finish A, make sure you go to send unit.
Since you're not a brain binder, why don't you get out all your physical this just table?
Yeah.
It's like
We're solving for x.
solving for x. If you're solving for 9, it would be very easy.
Oh, yeah.
Again, check with your neighbor after you finish the first one. Just make sure they're set. I'm going to call on 3 people in just a second. Are you ready? Two people ready. 3 people. 4. Oh, okay. Here we go. Nia, can you help us with number 4, please? I have 4 with A. I like that. Okay.
9 equals.
Log base 4 of 9 equals X. And it's,
Or I was done.
I squared. You put a box around it. Okay. Are we good with that? Yes. It just so happens here, once you change it from exponential to logarithmic, it's solved. So there's nothing else to do except put a box around it. But if you wanted to be fancy, we could realize that 9 is a special number, right? It's 3 squared, which means we could also write that as. And so log base 4 of 3 squared. So that's the same thing as 2 log base 4 of 3. But your answer is fine. It's fine to leave it as log base 4 of 9. Unless it says something like use the properties of logarithms to simplify completely. But it's fine as it is. You solve for X. I'm quite happy.
My exact form. Is that just like what?
It's what you did. Yeah, it's not typing in a calculator and getting an approximate answer. And thank you for remembering that you don't have to take the log of both sides. You can change it just from exponential to logarithmic. Very nicely done. L, could you help us with B, please? Okay, and you got rid of those parentheses, didn't you? Okay. Okay.
221.
Okay. Are we good with that? Oh, -3. Thank you. Do I need parentheses? Or is it clear as it is? Do we need parentheses around 21? I'd say it's clear. I'd say it's fine. For those of you who are uncomfortable with it, maybe you want to rewrite that as
I did -3 plus.
maybe this. Or if you want to use parentheses just to make sure that no one messes with the 21, it's acceptable. It makes sense to put them there. You know, I don't like that we began with that. It's too much. So it's up to you, really. Just don't make a 18 there. Al, thank you for your help. And Miley, can you help us with C, please? Or just tell us the answer that you got. Are we good with that? Okay, thank you very much. Nicely done. Okay. Solve the following equations. Leave your answers in exact form. I'll give you a moment to work through these. I think you can do it. I believe in you. Sure, that should. And make sure your neighbor is able to do A once you've finished. And you don't forget, you're not alone.
Yeah.
Did you get them? I want to make sure we're okay. If Chloe, can you help us with A, please? The first thing you did is divide by 2. So you got log base 3 of x plus 3 equals 3. Okay.
Like, I don't know how to express it.
You rewrote it as
Oh, x plus 3
equals what? So it seemed like you used the definition of logarithm to rewrite it. It's an exponential. Okay. And you got, of course, x equals. Are we good with that? One thing I have to be careful of with logarithms is that you don't have, what's it called when you have an answer that you get algebraically, but it doesn't work? Yeah, it can't be negative because that'll be extraneous. So just make sure that the answer could be negative, but you can't have a negative argument. You plug it in. Have I told you about that vocabulary word? The input of a logarithm is called an argument. So the argument can't be negative. It has to be positive. So that's not a problem here when you plug in 24. It's okay. Okay, thank you. August, did you get B?
Yeah.
What'd you get? Just answer.
X equals
13. Do we agree? Okay, thank you. And for C, Shiv, did you get that one?
I don't know, right? I got 2 minus x, or 2 minus e to the 5th.
2 minus e to the 5th. Do we agree with this? I'm seeing head nods. Do we need to go over any of this? Okay, thank you, Shiv. And thank you, August. Okay, there are different kinds of log equations. So far, the ones that we've done are form 1, where it's just a single log. But there's also where there's multiple logs. And I hope it makes sense that if log base a of x is equal to log base a of y, there's a very definite statement that follows. Do we agree that x equals y? Do you also agree that those parentheses are completely unnecessary? Okay, I'm with you there. And the reason we could say this is because log it passes the horizontal line test, which means it is 1-to-1. So there's no other thing it could be. X has to equal y. Just horizontal line test. Okay, so be careful. You're going to see some problems that look like this: log x plus log y plus log z. It does not imply that x plus y equals z. Right? It just has to be log equals a log to set the arguments equal to each other. So let's see what happens. I think you could do example 3 already. I feel like you should just talk about this with your neighbor. What's the first step? And then go for it.
Three plus get rid of all. We do that.
Yeah, you can.
Three plus x
And they
plus
say
4.
it's 10 to the third. Plus. Okay.
Okay, step 1. Who'd like to tell us what should it be? Yes.
2 logs on the left, you can just add it, and so you can multiply them inside the.
Very nice. We need to use the property of logarithms, that this is equal to log of AB. You can't just erase all the logs. So it becomes log of 3x plus 12. And then from here, now you could get rid, you can't really divide the log, but you could use a property that since it's 1-to-1, 3x plus 12 equals 5x minus 2, using some very advanced pre-algebra skills now. Use. If it's the same base, then if it's just a single log on each side.
There's no addition.
Oh.
Are we good? So please be careful about that. I know that at least 3 of you, if this were a problem like on the quiz next time or the test that we're going to have at some point, I think next week, is that right? I think next week. Some of you are just going to go and say that 3 plus x plus 4 equals 5x minus 2. And I'm going to be a little sad because I thought we communicated clearly, so just make sure that you have received this message. I want you to get these right. Speaking of getting those right, look, you have B, C, and D to work through. Getting all those right.
But so basically now that we know what to do. It's basically.
It helps to know
it's Yeah, but it is really bad.
Double on it?
Yeah. So get some subtraction instead of multiplication, maybe divide. Yeah, so x minus 5 over x plus
So Ellen. this one.
Isn't it x minus 5 over? Now we can just get rid of the island.
Oh, so
X
X
plus
plus
one.
one.
Example 4 looks like fun too, so don't let me stop you.
It's just one X.
Which is
X equal, times 3,
times
18 over 10, so wait, by 4. It's, 9 over 5, right?
4, 5, 5x equals 9.
You guys think that was a shot?
For B.
When you're ready, I'm gonna be calling up 5 people. Sorry, right now. Oliver, can you do B, please, when you're ready? Okay. C, Kayla, can you do C, please? When you're ready. Emma, D, please. Emma, you good with that? Whenever you're ready. Haley, example 4A, please. When you're ready. No rush. No rush at all for these. And Simran, happy birthday. 4B for you, please. 4B. When you get there.
Oh, so on the next day.
Yeah. What's that? Yeah. Please.
It's extraneous. If you plug it in, like if you plug your X in and this thing,
How did this?
like whatever's in front.
The argument is like, that's a problem.
That's the argument.
Yes.
The other things we've done.
Oh my God.
Go to the next page.
Example 3 and 4. So the people I called, you're welcome to come up whenever you're ready.
Minus X minus 6.
Oh.
So this log 3 or 4 2.
Yeah.
Wait, x squared minus x minus 6 equals
I'm 4B,
x
right?
equals 3.
Yeah.
Wait, what did you finish it? X squared minus x. Wait, I made it again. Wait, yo.
I got this.
Minus 4.
So it's minus 1.
No, minus 20, right?
How come there's no
Negative 3 and 2.
actual consistency?
It's not feels.
Yes, please.
I think so too. I think.
Right, so 5 and 4. So x
Yours just got one plate, one.
minus 5 x plus 4.
Yes. Okay, you. Good.
Yeah, let's send that back.
It's like.
No.
Yeah.
You get a weird answer for 4B.
I'm almost.
Answer strange.
Okay.
Oh my god.
I'll have a feeling about it.
How do you do
I'm not a nice number.
Yeah. I'm
I
almost.
thought it was. What are we doing with the 3?
I wish there in B there wasn't the 2. That would make it so easy. Why did you put 2 to the other side? How does that help?
It's not easy this year.
To do a deep dive.
Instead of. I don't want to be.
Yeah, I get it. minus log. X minus seven
Yeah.
equals 2. Now it just x over x minus
Oh, did you
7.
finish the?
Oh, then you do need that.
Multiply.
You have to make the other side long. Yeah, just do that.
Who's doing C again? I already called someone for C. Emma, Kayla's doing C and Emma, you're doing D, right?
If you add log to both sides, just get rid of the log.
Yeah. Then you still have it.
We can have log 2, so x over x minus 7. And then we multiply out the x minus 7.
So then, okay. That's 10.
7 point.
So 10 to the this equals 2.
You just ran it out that much, like,
Right? Log 10 of 2. So log 10
Like,
times
yes.
that.
So 10 to the absolute.
That's
Oh,
4. Wait, I got negative 8.
2.
Yeah, but how does that?
I would be max. I'm done.
Yeah, but absolute.
No.
For B.
Oh, what is that?
There's been one that basically gave out like. I asked her one time.
Same as like the single.
Oh my god.
No, Nathan.
I don't need your
focus
friend.
on the only best part about it.
I did it.
Sorry.
I can help you.
Nathan, no.
Nathan. You don't want my help? I think you need my help. You know.
No, you're a two.
No,
No, Nathan would watch you. Yeah, I'm just like, I know you.
Can I check something?
Oh, wait, great.
Negative supposed to be.
I
Well, me.
Please,
Oh, this is very.
I would not.
I was like,
recommend
not
that. I would recommend anyone else. Nathan, you're trying to be a tutor and you're asking how someone needs.
For B.
It seems like the question.
Hey.
Yeah.
No.
I think so.
Nathan, me.
Yeah.
What are we doing this last week? Wait.
We're wearing it.
It's already done.
Just.
You're just like.
Is someone supposed to do 3B? It's not me, right?
They're all being done. They're done, yeah.
Oh, that.
Oh, thank you. Ah,
First felt right. I'm sorry.
is it right?
Yeah, that's right.
It is.
You're about to get like sacked.
Oh, I forgot about that. Extraneous.
One timeout. I don't know.
That's how you get like your. Oh, that's how the Indian state. That's how you get. Oh. No, he's on. You're watching me.
Oh, no,
That's now, they're doing that. Oh, wait, no, I'm sorry. Wait, this kind of fun. It's getting easier. I'm supposed to do steel. Oh, we were doing steel.
No.
Did you take the log of the? Oh my god.
We did all that. Mr. Lieberman, how did you celebrate the new
You
year?
guys have a meeting?
I watched the Japanese variety show, traditional Japanese variety show, yeah. How about you? That seems more fun. That sounds good. Okay, folks. So for logarithmic equations, you just have to make sure that any solution you get doesn't blow up the math. So make sure that none of the arguments are ever negative, right? So none of the answers are extraneous. Is it okay to plug it in 9/5 here? And it's okay, this first one. 9/5, times 3 is 27 fifths. I think we're okay. Yeah, just barely, but it's good. It works. -4 doesn't work. Are we sure about that? Yeah, it kind of fails immediately in the original problem. So thank you for keeping that in mind. D, are we good with that? Okay. For A, so x equals -8, is that acceptable? Oh, no, it's extraneous. That's okay. Adios. Yeah. So this question has no solutions. And the last one, 799, is that right?
Yeah. That's what I got.
Nicely done.
For four, would you want us to write yes or no?
No solution. If it's asking what kind of a solution x equals -8 is, then you would say it's extraneous.
Oh, no, but that one has.
But don't we need to write extraneous too, Tim? Like our reasoning for why it's no solution.
I'll know what you mean if you cross it out. Yeah. Are we good? Is this a comfortable way back into the school year? I hope so. It's not like too easy and it's not too hard. It's kind of just right. It's a Goldilocks. Just a couple more equations. For A, should you do logarithms here or something?
No, you can get rid of the two.
Yeah, because these functions are called one. They're 1-to-1, so we could just take those exponents. 1-to-1. Do I like what? I don't know that.
Use the late you sing the song that is about these types of problems.
Really?
Yeah.
That's a
101.
one of them.
Yeah.
Oh.
But he spells it different.
Suppose he does,
That's okay. As long as I don't use extra parentheses, I'm quite happy. Try B, C, and D, please. And make sure your neighbor is comfortable with B.
Wait, what? Yeah, I said. I made like two.
Yeah.
Yeah.
So smart.
9x.
Anybody can read it.
Yeah, I'm not even tell me that.
Oh, can't.
8x, 11x.
What? Hold on. 3x minus 2 is equal.
8x equals 11.
3x minus.
Wait,
Three, right?
Oh, okay.
I like these problems.
Yeah.
These
Go
are-
back to our roots.
These are friendly little problems. Yeah. I don't know why they put them at the end.
Wait, B, hold on.
Jonas, can you tell us what you did for B, please?
Basically, they turned 8 into a exponential two. So basically, you multiply 3x times 2 by 3.
Okay.
And then, yeah, you basically do that, and then you get to, and then you just can cancel out the base, and then you get
Minus
9x minus 6 equals to that.
And then you get x equals
Okay.
11/8, you said?
Yeah.
Are we good with that, everybody? Thank you. Nicely done. Connor, what did you do for C?
I did a similar thing.
Okay.
I did 3 to the 2 times 2x.
Okay.
3 to the 3 times x plus 3.
And can you tell us what the final answer is? 6? Okay, do we agree? Nice, thank you. And lastly, and Leah, I apologize. I didn't get to you today, but I'm gonna get to Leah. Leah, what can you tell us what you did for D? And can you tell us how you did that?
Switched it around, put a question like 2 to the -5x -7.
Nice.
And the other side I got 2 to the 2x.
Okay, and then you said x equals -1 in the end is what it worked out to be? Okay. Any questions? Maybe your question is, can we try some more? The answer is yes. At home, you can try some more. Sorry, we're done for today, folks. Great job. Welcome back. Happy New Year. Looking forward to more fun times. And 45 minus I, 45 plus I. Here. It's on Pearson. My pleasure. My pleasure.